welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we are going to start with your physics class, and that is your class 34th class of the session. Here we had started with unit 13 in the last classes, which is your laws of motion, and where we had done your Aristotle fallacy and the theory about it, and which is your the ideas on emotions in ancient Indian science that we had cover-ups. If you had not visited yet, you can go ahead with like, share and subscribe, and we'll go through the playlist. You will find out each and every video there. In the same way, today we'll start discussing about the law of inertia that we have. In terms of law of inertia, that is very important topic and that you have to cover up as well. So we'll start discussing about the law of inertia with the diagrams as well. So that is very important. So let's get started. The law of inertia. This is very important topic. You can just mark it out. And before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even you can also enjoy the video as well. In terms of law of inertia, here Galileo that studied the motions of object on an inclined plane. Objects that is moving down an inclined plane accelerate, while those moving up retard, and the motion on a horizontal plane is an intermediate situation. Where Galileo concluded that an object moving on a frictionless horizontal plane must neither have acceleration nor retardation, and it should move with constant velocity. So these were the three that is about the plane or motion of an object of an inclined plane objects, and that all the three has been concluded here. So we'll write it down one by one. So Galileo studied motions of an object of an inclined plane objects, that is first they had concluded moving down an inclined plane accelerate, while those moving up retard. And the third one, motion on horizontal plane is an intermediate situation. Here Galileo concluded that an object moving on a frictionless horizontal plane must neither have acceleration nor retardation. So what Galileo has been concluded, Galileo concluded that an object moving on a frictionless horizontal plane must neither have acceleration not retardation. That is, it should move with constant velocity. So where in that another experiment by Galileo that is leading to the same conclusion involved a double inclined plane, and for this conclusion he had done an experiment which is this is a seesaw type, no seesaw नहीं, वो जो बच्चों का होता है inclined plane. This is a ball. If it is an inclined plane, so it will go towards downward. Okay, this is the first one, and then another. This is a okay, and this is the second one. This is the third. Now, another experiment done by a Galileo that is leading to the same conclusion that involve a double inclined plane and a ball released from rest on the top of the plane and rolls down and climbs up the other. If the plane are smooth, the final height of the ball is nearly the same as the initial height. So for that, a little less much but never greater. In an ideal situation, when friction is absent, the final length of the ball is the same as its initial height. Same if the slope of the second plane is decreased and an experiment repeated, the ball will still reach the same height, but in doing so, it will travel a longer distance. In a limiting case, when the slope of the second plane is 0, that is the horizontal, the ball travels an infinite distance. In other words, its motion never ceases, and this is of course an idealized situation. So we'll go for it. This is for first one. This is second category. It will move towards this only, and the third it will go with the plane. ये यहाँ तक की सरफेस है तो ये यहाँ तक गया है. अगर इसकी हाइट मान लो मैं बढ़ा देती हूँ यहाँ तक की, तो it will go up. This is its height, the ball height. And अगर मैं इनको प्लेन सरफेस पे रखती हूँ तो that will be the on plane, that is the height of a ball here. You can just write it down and draw the figure as well. So in these cases, the law of inertia was inferred by Galileo from the observation of motion of a ball on a double inclined plane. Now, in detail about it, in practice, that the ball does come to a stop after moving a finite distance on a horizontal plane because of the opposing force of friction, which can never be totally eliminated. However, if there were no friction, the ball would continue to move with a constant velocity on a horizontal plane. Galileo thus arrived at a new insight on motion that had eluded Aristotle and those who followed him. The state of rest and the state of uniform linear motion with a constant velocity, are equivalent in both cases, and there is no net forces acting on the body, and it is incorrect to assume that a net force is needed to keep a body in uniform motion. To maintain a body in a uniform motion, we need to apply an external force to encounter the frictional force, so that the two forces sum up to the zero net external forces, where, to summarize, if the net external force is zero, a body at rest continues to remain at rest, and a body in motion continues to move in a uniform velocity. This property of a body is called inertia. Inertia means the resistance to change. Just write it down. Inertia means resistance to change. Where a body does not change its state of rest or uniform motion unless an external force compels it to change the state. Now we go for another one, which is the Newton's first law of motion, which is also important one here. Newton's first law of motion. Then we have your Newton's second law of motion, Newton's third law of motion. So before starting with the Newton's first law of motion here, we'll discuss about the Galileo 1564 to 1542. So let's go for it. Discussed here. Galileo 1564 to 1642. In this, basically a Galileo Galilei, that is born in Pisa, Italy in 1564, was a key feature in a scientific revolution in Europe about 4 centuries ago. Galileo proposed the concept of acceleration from experiment on motions of body and inclined plane of falling freely. He contradicted the Aristotelian notion that a force was required to keep a body in motion, and that heavier bodies fall faster than lighter bodies under the gravity. He thus arrived at a law of inertia that was the starting point of the subsequent epochal work at Isaac Newton. Galileo's discoveries in astronomy were equally revolutionary. In 1609, he designed his own telescope, invented earlier in Holland, and used it to make a number of static observations, mountains and depressions on the surface of the moon, dark spots on the sun, and the moon of the Jupiter, and the phases of Venus. He concluded that the Milky Way derived its luminosity because of the large number of stars not visible to the naked eye. In the masterpiece of scientific reasoning, reasoning, the dialogue are a two-shift world system. The Galileo advocate the heliocentric theory of the solar system posed by the Copernicus, which eventually get universal acceptance. With Galileo came a turning point in the very method of scientific inquiry. Science was no longer merely observation of nature and inference from them. Science meant devising and doing experiments to verify or refute theories. Science meant measurement of quantities and search of mathematical relation between them. Not undeservedly, many regard Galileo as a father of modern science. That's what we have discussed here. Now we'll discuss the rest of it in the next coming class, which is on Newton's first law of motion, which is in 13-5 classes. So here we're going to end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you.